Hi everyone, Assalamualaikum. First, let me introduce myself. My name is Madam Amirahana binti Muhammad Noor, and I will teach you Foundation of Applied Mathematics MAT 238, right? Let's look at what inside this course, alright? There are 4 major chapters under this course, okay? The first chapter is inverse trigonometric functions, okay? The second chapter will be hyperbolic and inverse hyperbolic function. Okay. Chapter 3 is integration technique. And chapter 4 will be ordinary differential equation, ODE, right? In this video, we will discuss chapter 1, which is inverse trigonometric functions. Okay. Alright, now let's look at what inside chapter 1, which is inverse trigonometric functions. Okay. Here are the list of topics under chapter 1, okay, which is inverse trigonometric functions. Okay. The first topic is introduction, containing notation, properties, and their graph. Okay. The second topic will be evaluating inverse trigonometric functions using triangle method. The third topic is derivative of inverse trigonometric functions. And the last topic under chapter 1 is integration of inverse trigonometric functions. Okay? Alright, in this video, we will discuss introduction, containing notation, properties, and the graphs of inverse trigonometric functions. Right? Alright, before we go further, first we got to know about the inverse trigonometric function. Right? Each of the trigonometric functions, sine, cosine, cotangent, secant, cosecant, and cotangent, has an inverse with a restrict domain. Right? Alright, the inverse is used to obtain the measure of an angle using the ratios from basic right triangle trigonometry. Alright? For example, the inverse of sine is denoted as sine -1. Okay, we read as inverse sine or arc sine or a sine. Okay? Alright, from here, sine -1 here means inverse sine. Okay? This does not mean sine to the power of -1. Okay? This is not equal to sine to the power of -1, but this means inverse sine. Okay? Or arc sine or a sine. Alright? Alright, now let's look at the notation of inverse trigonometric functions. Okay? If we have sine x equals to a, okay, we can write x equals to inverse sine a. Means we can move ordinary sine here. We move to right hand side. So the symbol become sine -1. Or we read as inverse sine. Alright. If we have cos x equals to a, okay, we can move ordinary cos to the right hand side. So we have x equals to inverse cos A, right? Let's say if we have tangent x equals to A, okay? We also can move ordinary tangent to the right hand side. So we can write x equals to inverse tangent A, right? If we have set x equals to A, we also can move ordinary sec to the right hand side. So we get x equals to inverse sec A. Alright? If we have cosec x equals to A, we can move ordinary cosec to the right hand side and we can write x equals to inverse cosec A. And the last one, if we have cot x equals to A, we can move ordinary chord to the right hand side and we can write x equals to inverse chord A. Alright? Alright. Now, let's look at other names for the inverse trigonometric function. Okay? Sometimes inverse sine is called a sine or arc sine. Okay? Likewise, inverse cos, okay, is called a cos or arc cos. And inverse tangent is called a tangent or arc tangent. Okay? This not equals to trigo to the power of -1. But this means inverse trigo. Alright? Got it? Alright, now we look at the properties of inverse trigonometric functions. Okay? Alright. The first one, if we have composite function between ordinary sine and inverse sine x, we can simplify and we can write x. Okay, same goes to if we have inverse sine outside and ordinary sine inside, so we still can simplify and we get x. Okay, if we have cos composite with inverse cos x, so we get x. Okay, and if we have inverse cos outside and inside is cos x, so we still can simplify and we get x. Okay, the third one, if we have ordinary tangent composite with inverse tangent x, so we can simplify, so we get x here. Okay, and if we have inverse tangent composite with tangent x, we also can simplify and we get x. Okay, if we have sec composite with inverse sec x, okay, the answer equals to x. And if we have inverse sec composite with ordinary sec x, okay, we also have x. Okay, if we have cosec composite with inverse cosec x, the answer equals to x. Okay, and same goes to if we have inverse cosec composite with cosec x, we still have x. Okay, and the last one, if we have ordinary chord composite with inverse chord x, we can simplify and we can write x. Okay, and if we have inverse chord outside and inside is ordinary chord x, we also can simplify and we get x. Okay, alright, basically when we have trigo function, the same trigo function and inverse trigonometric function, okay, the same function, sine inverse sine, cos inverse cos, and so on, we can simplify and we get x here if the variable here is x, right? Alright, now we look at the graph of inverse trigonometric functions. Okay, here are the graph of inverse trigonometric functions. We have 6 graphs here. Okay, this is the graph of inverse cos, the graph of inverse sine with the given domain and range. Okay, this is the graph of inverse tangent with the given domain and range. This is the graph of inverse sec x, the graph of inverse cosec x, and this is the graph of inverse cot x. Okay, the graph of inverse trigonometric function here is found by reflecting the graph of ordinary trigo function through the line y equals to x. So we get this graph, right? Coming up next, procedure and useful formula to evaluate inverse trigonometric functions using triangle method. Okay? Thank you for watching. Stay tuned. If you like this video, you can subscribe. Thank you. Bye.